Hello, ladies and gentlemen. This is the last one for this week, and then we'll go on to something different next week. But I just wanted to get this last 1.6 pre-cal recording made. We're talking about linear programming today. Oh boy, that'll be interesting. That's something new. But just want to make certain I state it one more time. 28 days, everything closes, so you got to get them done in that time frame. If it's taking you a little while to get a few of them done, don't panic. Just do what you can, and they'll be there tomorrow. Trust me. They don't go anywhere. Okay? So we'll get them all done before too long. I'm not too worried about it. Now, what we're actually looking at is topic 1.6 that talks about linear systems. Linear systems is something that in Algebra 1 you covered it. It was probably the last topic you did. It was after you got ready to go take the STAR test or the TAKS test, whichever one you took, and it wasn't one of those big major topics that everyone was paying a whole lot of attention to, and you probably slept through it a little bit if you want to know the truth. I know most people do. I did when I first took it in Algebra 1. But it's where they had two equations with two unknowns, and you had to try to solve that. And you were sitting there going, oh, God, this is confusing. Two equations, two unknowns. How do I do this? Well, they gave you a couple of methods. One of them was a graphical method. If you graph the two linear lines, they intersected. That intersection was the point that you were looking for. That was an easy method if you could do the graphing. And, I was never all that great, so graphing wasn't the one I looked at all that much. Another one they called substitution. Substitution was if you could solve for one of the two variables easily, don't spend a whole lot of time doing it, but easily. If you could solve for a variable, you could take that equation for that variable, substitute it into the other equation, and you could solve then for a number. And you would get that variable is equal to a number. And then you could go back and substitute it into the other equation to find the other number that you were looking for, the other point. It worked very nicely. I liked that one. That was my favorite one, substitution. Then they came up with this elimination method where they put two equations and they had to multiply one of them by a number to expand it so that the constant in front of a variable was equal, and then they would subtract one from the other, and they'd wind up with an equation down there that was in just one variable and they could solve it. Ugly, but it works. Okay? So those were the three methods that they gave you for solving linear systems. Always a fun time. And then you go to Algebra 2 and they start talking about matrices. Oh no, the Matrix. I remember that movie with the little spots flowing down and then plugging those things in the back of their head. Oh, that was terribly scary. But you know what? Matrices worked, and I could do matrices. For example, if they gave me equation 2x plus 3 or minus 3y equals 21 and 6x plus 14y equals 43. You know what? I'm making those numbers up. I don't have a clue if this is going to work out to be a good equation. It would be hard to solve this one, wouldn't it? Well, handy dandy calculator here. Always pull up the calculator because matrices required me to use a calculator. What I did it was I would come up with a matrix, and my matrix had two equations in it, and it had 3 points in it. Three? Where are you getting three, Mr. Green? Well, I would have 2, -3, and 21 in the first line, and I would have 6, 14, and 43 in the second line. Okay, I see where you're getting those numbers from. How does that help me? Well, I'm going to press second matrix on my calculator. I'm going to go over here to edit, and I'm going to press enter. I'm going to tell it I have a 2 by 3 matrix, and my numbers are 2, -3. I didn't like that. What did I do wrong? Try that again. Second matrix. I'm going to go over here to edit, hit enter. It's a 2 by 3. So it had 2, it had -3. It's not liking that. I don't know why. Okay, let's try that again. Second, matrix, go over to A. Oh, look at what I'm doing this time. 2 by 3. That's 2, that's fine. 1 is 2, yep. And then this one, I'm going to clear it first. And then I'm going to put in here a -3. Oh, wait a second. Maybe that's what I'm doing wrong. Maybe that's a minus sign. I'm going to press the negative sign this time. Okay. Move the calculator up just a little bit so I can get to the negative sign. -3. It doesn't like the negative on the keyboard. I keep forgetting that. Yep, that's what it was. And 21 is my last number there. Press enter. And then on the second line, I'm going to enter 6, 14, and 43. And I can press enter. Now I've got my numbers in my matrix. I'm going to do a real quick little trick on you here. I'm going to do matrix. I'm going to go over to math. And under math, I'm going to skip down here just a little bit. And I want to do an RREF. That one right there, number B. RREF. And if I press RREF, no, that's wrong. 43 was correct. 43, press enter. And get out of this first. Quit. Thank you. Now I'm going to press second, matrix, and go over to math and do an RREF. Calculator is the slowest thing on my computer. There it is. RREF. Press enter. And I'm going to stick that matrix in here. Second matrix, and it's matrix A. So I'm going to press enter for getting that one in there. Close my parentheses and hit enter. And it will solve it for me. See how it's got this 1 here? That's my x value. This one here is my y value. X is 7.5. Y is -2. I found the point that works for this as 7.5, comma, -2. Now what I had? 7.5 -2? Yep, 7.5 -2. That's the solution to that one. So, hey, a new calculator trick you learned using the matrix. Ooh. You can go to your friends and say, oh, I can do some matrix tricks. Okay, enough of that. Okay, what else are they going to do? They're going to take the linear inequalities that we did in the last section up here, and they're going to use those down here too. What do you mean, Mr. Green? One of the things in real life is we very rarely have true linear equations. What we typically have are boundary type equations, okay? And if you look at it from that perspective, you sometimes need to do things called linear programming, okay? Linear programming in this situation, this one right here, is a really good example of it. It's a fitness shop that's wanting to mix two things together. One of them is nuts or they're mixing what? Nuts and dried fruit together. Okay? And there's all sorts of constraints in here. If you watch this one real closely, they give you the table information here, now. And they're going to show you that if you graph those things out, you get a feasibility region for where things work. And you can look at these points that are at the corners and evaluate these points at the corners. And by doing that, it'll tell you which one makes the most money. I can tell you right now, it's going to be this one right there. Okay? That one makes the most money, but you've got to find that and work through it in a feasibility study. And this example they give you is excellent at doing that. Okay? So you ought to work through their example quite a bit and make certain you understand it. Okay? Yeah. And so, linear programming. Define your variables, list the given information, write a linear inequality. It's also called the constraints. Graph the linear inequalities, find the corner points, evaluate the corner points, and answer the question. That is the way you go about doing linear programming. Well, That's enough for this week. I will see you next week with more recording.